Alright, you guys, today you're going to watch a video on the rational root theorem, and hopefully by the end of the video you'll be able to find the real zeros of a polynomial function. Now realize the last couple of days we have been finding the zeros algebraically through through factoring. You've been given factors to go through that process to find the zeros, but now you're going to deal with a larger degree polynomials, as well as a few cubics and quadratics here. However, that won't be able to be, basically they're not as easy as the other ones, okay? So we're going to go ahead and get started. The rational root theorem describes how the leading coefficient and the constant term of a polynomial function can be used to determine a list of all possible rational zeros. So we're going to look at the number in front and the number at the end to determine our list for our possible rational zeros. Now don't forget, okay, that rational numbers can be integers, okay, positive or negative, and fractions, okay? So realize that when we're creating this list, we could have positive numbers, negative numbers, and also fractions that could be positive or negative. So the rational root theorem says that if f is a polynomial function with a degree where n is greater than 1, with integer coefficients and a sub 0 does not equal 0, meaning that the leading coefficient does not equal 0, then every rational zero of f has the form p over q, where p are the factors of the constant and q are the factors of the leading coefficient. So to find your possible rational zeros, you're going to take all the factors of your constant, all the factors of your leading coefficient, and you're basically going to create a list of different numbers. So we're going to start, and we're going to list all the possible rational zeros of each function, and then we're going to determine which, if any, are zeros, because there may be the possibility that you find your list of possible rational zeros and none of them are zeros of our polynomial function, which will mean that we're either going to have complex zeros, such as imaginary ones, or we're going to have ones that have like a square root or something like that, okay? All right, so what we're going to do is we're going to list out our p's and our q's. We're going to mind our p's and our q's. So if we take a look, our constant is our p, and our leading coefficient is our q. So all the factors of p, basically what numbers multiply to give you 1? Well, just 1. And realize that it's not just your positive numbers, but also your negative numbers as well that will work as your factors, okay? So realize it's going to be your positive and negative versions of these factors. And then here, our leading coefficient is 1 as well. So our factors here are positive 1 and negative 1. Awesome. So now we're going to create our fractions. We're going to do our p's and our q's. So we're going to put all of our p's, okay? We'll put these in red. So that's 1 and negative 1. And we're going to put them over each one of our q's, which I'll put in purple. Okay? So each factor of p has to go over each factor of q. So positive 1 has to go over positive 1, as well as negative 1. And negative 1 has to go over positive 1, as well as negative 1. Do you guys see how that goes? It goes over each one of your factors. So we will have the positive 1 and the negative 1. Now if you look, this one again is a negative 1, and this one here is a positive 1. But once you already have that particular rational zero written down, you do not have to write it again. So these are our possible rational roots. Now to figure out which ones are actual rational roots or rational zeros of this polynomial, we're going to use synthetic division, which we went over in lesson 12. So we're going to use synthetic division with 1 as well as with negative 1. And if they are indeed a 0, that means that our remainder should be 0. Okay? So we're going to use 1 and negative 1. We don't have to worry about switching the sign here because these are supposed to be our zeros. And we actually plug in our zeros in the backwards L when we're doing synthetic division. So we're going to write down our coefficients. We'll have 1, we'll have 0, because we need a placeholder for the x squared term that's missing. okay? So that x squared term is missing, so we add in a 0, then 2, and then 1. And then we'll proceed with our synthetic division process. Break down the first term, multiply, add, multiply, add, multiply, then add. As we see here, our remainder is 4. So that tells us that 1 is not one of our actual rational zeros. So we're going to do the same thing for negative 1. Okay? We're going to use the original function here, write them out, again perform synthetic division. Bring down our first term, multiply. In this case, we're going to subtract. Multiply, add, multiply, add. As we see here, 2 is our remainder, not 0. So that means that negative 1 is not an actual rational zero. So in this particular case, there are no rational zeros, roots, or x-intercepts for this particular function. Now that doesn't mean that there aren't any real ones. They just might not be rational. They might be irrational, such as like 1 plus or minus the square root of 3, or something like that. Let's look at the next example, okay? So we need all the factors of p, put that in red, and we're going to need all of our factors of q, which in this case is 1. So all of our factors of 9 are 1, 3, and 9, and don't forget it's plus or minus every single one of these. Now we'll have our factors of q, which is 1, so we're just going to have plus or minus 1. So now to do our p's and q's, remember every single p has to go over every single q. So positive 1, negative 1, positive 3, negative 3, and positive 9 and negative 9 all have to go over positive 1 as well as negative 1. Okay, now realize that I know some of you guys are like, well, do I have to write all this down? No, you don't have to write all this down, okay? Because you might be able to go through and just kind of point and write down your rational zeros as you're going along, okay? But for those who may struggle, this might be helpful for them to see which ones they don't need to continue to write over and over again, okay? So we're going to have 1, negative 1, 3, negative 3, 9, and negative 9. Over here, this one's negative 1, which we already have. This is a positive 1, a negative 3, a positive 3, a negative 9, and a positive 9. Remember, we don't have to write it multiple times if we already have it. So now we're going to test and see which ones are actual rational zeros. Now, the thing is that we don't have to test all 6 of these, okay? Since this is a quartic or polynomial with a degree of 4, we really only need to find 2 of these to be rational. Because after that, when we do synthetic division, we'll have a quadratic, which we can just factor normally, and then find any other rational zeros that way as well. Because sometimes these lists can be very, very long, and so to save some time, if you can just find 2, that's all you really need. I hope you guys understood that. So we're going to do synthetic division with our zeros until we can come up with 2 that work. Okay, so I have 1, 4. You see how I'm missing that square term, so I need to put a 0, negative 12, and negative 9. So synthetic division. Bring it down, multiply. You continue the process. So this right here tells me that 1 doesn't work. So that one's out. Okay? And actually, let me not do that. Let me just make a note that this one doesn't work. Because the question did ask for all of our possible rational zeros, so I definitely don't want to cross them out because you definitely don't want to say, hey, Ms. Anderson, these aren't real. I just messed up. So let's do the next one, negative 1. Continue to do synthetic division, bring down the 1. Found 1, -1 works, okay? And just like before with the lesson 12, if one of the zeros works, then we can use the result that we got after we divided and to find the next one, okay? So I'm going to use this, and I'm going to go to the next one, which is going to be a +3, okay? So I'm going to do +3. Bring down 1, and go forward. But unfortunately for this one, 3 doesn't work, okay? So since 3 doesn't work, I still got to find one more. I found 1, I just need to find one more. So now I'm going to go back to that line, this line right here of 1, 3, -3, and -9, and I'm going to use that line and then test my next rational 0, which is -3. Bring down the first and proceed with my process. Hopefully you caught that error that I did, because I caught it. I accidentally wrote a +3 when this should have been a -3, making this a -3 here, making this a +9. So in actuality, -3 does work, okay? So right now I know that -1 for sure and -3 for sure are rational zeros. So this brings me down here. This is a quadratic, and unfortunately I can't factor this because 3 is not a perfect square, and so it's not like I can say, you know, x plus a number and x minus a number to get the other rational ones. The other 2 zeros are actually irrational. So for this particular problem, my only rational zeros are -1 and -3. If at any point in time you need to pause this video, go ahead and do so. Okay, this is for you. Take your notes and take your time. Go ahead and try the next one on your own. So pause this video, try to work it out, and then press play when you're ready to see the answer. So I have my P's and my Q's, all my factors of P and all my factors of Q. This one just happens to be a long one. You have a lot of factors here, okay? And so my P's and my Q's, my possible rational ones are ±1, ±2, ±3, ±5, ±6, ±10, ±15, and ±30. That's a lot of zeros that we are going to have to test out here, okay? But again, this is a quartic, so all I need really are 2 of them to be rational, to be real and rational, so then that way if I need to, I can just go ahead and possibly factor that remaining quadratic, okay? So I'm going to go ahead and do synthetic division. So here's the synthetic division that I did so far. I went through 1, -1, and I went to 2, and I found out that 2 did work because I got a remainder of 0, okay? And then I also knew that -5 would also work. And so I went through and I did synthetic division. Hopefully you did. I know it takes a long time, and I know you're like, gosh, it's such a tedious process. But once you find them, you'll see that you have 2 and -5 as your rational zeros for this particular polynomial. And then when you look at what's remaining, you have x² + 3, which cannot be factored. So 2 and -5 are indeed your rational real zeros here. Now, when the leading coefficient is not 1, okay, you still go through the same process. You still find all your factors of P, and you find all your factors of Q. But this time, do be aware that you might have some fractions here, okay? You might have some fractions here. So you're going to list out all of your possible P's and Q's just like before, okay? And I'm going to go ahead and I'm going to kind of take a little shortcut here. I know that plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8 are my factors of my constant. And I know that plus or minus 1 and plus or minus 3 are the factors of my leading coefficient. So I know that my possible rational zeros are going to be plus or minus 1 over positive 1 and negative 1. Okay? So that's a positive 1, that's a negative 1. I know I'm going to have 2 and negative 2, and then 4 and negative 4, 8 and negative 8. So whether they're over a positive 1 or a negative 1, these are going to be my zeros. Now I'm going to take this positive or negative 3, and that's going to end up being my denominator over all of my p's. So that's going to give me a positive 1/3, a negative 1/3, a positive 2/3, a negative 2/3, a positive 4/3, a negative 4/3, and then a positive 8/3, and a negative 8/3. These here are all of my possible rational zeros. And I will start at the beginning of the list and work my way through and do synthetic division until I can figure out which one is a rational zero. Okay? So if I go through the process, I'll come to find out that negative 2 is one that works. So I have negative 6, that's a negative 13, that's a positive 26, positive 4, that's a negative 8, with the remainder 0. So negative 2 is one of my rational zeros. Now do realize, since this is a cubic, I only need one of them. I don't have to keep testing all of them, because I can take this here, this quadratic, and then factor it to find my other possible rational zeros. Okay? So I'm going to do California method. I get 12. Two numbers that multiply to give you 12, that add together to give you a negative 13, or negative 12 and negative 1. A 3x goes on top. And then I'll come to find out that 3x minus 1 and x minus 4 are the factors here. Set that equal to 0 and solve to find out that x equals 1/3 and x equals 4. Now I very well could have found that out, because if I look at my list, 4 is there and a 1/3 is there. So if I kept on going my synthetic division, eventually I would have found the other two. But I don't have for you guys to go through the whole synthetic division process, get through all your zeros, just to come to find out that none of these other ones are indeed rational zeros. So go ahead, once you find one, use what you know about quadratics to find the other ones. When it's a quartic, all you need is 2. Find the 2 and then factor. Try this one on your own. List out all of your possible rational zeros and then test and see which ones actually work. This is a cubic, so that means you only need to find 1. And then you factor the quadratic to see if you can find the others. So for this one, we had a lot. You have all of these rational zeros. Of course, you have all of your p's over plus or minus 1, so that's the top line. Then you had all of your p's over plus or minus 2. Now see, the thing is that when I do 1 over 2, I get plus or minus 1/2. But when I do 2 over 2, I get plus or minus 1, because I reduced that. I don't need to write it again if I have it already. 3 over 2 is a plus or minus 3 over 2. 4 over 2 is a plus or minus 2, which I already have. 6 over 2 is a 3, I already have that. 9 over 2, I have a plus or minus 9 over 2. And then 12, 18, and 36, when I divide them by 2, I get 6, 9, and 18, which I already have. So these are your possible rational zeros. And if you do synthetic division, you'll realize that 2 works. So not too long, you only have to do it 3 times. 2 would work to get you 2x squared minus 18 equals 0. You can factor out a 2, a GCF, leaving you with x squared minus 9. X squared minus 9 is a perfect square, so that can be factored to x minus 3, x plus 3. Then you set both factors equal to 0, and see that x equals 3 and x equals negative 3 are your other rational zeros. So my answers here are 2, positive 2, positive 3, and negative 3. Again, you could have kept doing synthetic division, but I would hate for you to do all that work just to find out that there's a possibility that all of these rational zeros don't work. Find all the zeros for this problem here. Find all of them. So you're going to go through the same process again. So pause this video, try it on your own, and let's see if you get it. Did you get these as your possible rational zeros? I hope so. Now let's see which ones are actual zeros. Did you get your rational zeros to be -2, -3, and +4 up to this point using synthetic division? I hope so. And you only had to find 3 here because it was a 5th power polynomial, which means that all you have to do is find 3, so that way you can get down to your quadratic here of x squared plus 1. Okay? So we're going to set that equal to 0 because this is different. This is a problem that's a little bit different because it says to find all of the zeros. So we have 3 of them from our list so far, and now I'm going to go ahead and solve this one so that way I can get my last 2. So I'm going to subtract 1 over, take the square root, and remember, whenever you take the square root, you get a positive version and a negative version of that number, and the square root of a -1 is I. So our last 2 zeros are actually imaginary ones. So here we go. Here are all 5 of my zeros. -2, -3, 4, I, and a negative I. Hope you guys got that. Let me know if you have any questions. You can always shoot me an email, a message, and I'll get back to you guys. Hopefully before you pause this video, you'll be able to see this last little bit. If your first, third, or fifth period, you guys are going to have a test next Thursday. And if your sixth period, you're going to have a test on Friday. This test is going to cover lessons 7 through 13. Okay, that's continuity all the way up to this lesson. Sixth period, we've already tested on lesson 7, so yours is only going to cover 8 through 13. This is sixth period only. First, third, and fifth. Yours is 7 through 13. Sixth period is only 8 through 13. It's going to have 4 standards on it, and these are going to be the last things that go into the grade book for the first quarter, which is over on the 28th. Make sure you go ahead and finish up that work that the sub has left for you, and I will see you guys around.